our model is really a frontier-grade model for physics rendering, high-speed camera motion, really dynamic human movement. And so it's not just kind of panning the camera like I think a lot of video generation products do, but it actually synthesizes real motion. And that was a really important thing here. And so I think continuing here, what I'm really excited about is how do you make a video with diffusion models? You know, our team was some of the people, include some of the people who actually pioneered the original diffusion models. And you know, you have essentially a process that from noise, you know, creates images. And I think it's really incredible. You know, one of the critical things we did to enable this in Mochi were large-scale ML systems to enable long context. And so what this means here is a typical video actually has millions of pixels. In fact, if you look at one of the clips I showed previously, there's order 60 to 70 million pixels just in that single image. And so it's incredibly numerically dense. You know, this would be tantamount to writing, you know, thousands of books with a single LLM generation. You know, and Llama 1, for example, had a 2048 context window, and that has gone to 4096 and then, you know, 8K. But Mochi operates today at a 44,500 token context window. We're quickly growing this. And so I think it's actually quite feasible video models eventually have million token context windows. We open sourced a lot of our innovations around how to actually perform long context inference to support the community and be able to actually, you know, access this technology in a scalable way. We also introduced a new architecture. So Mochi 1 actually uses a new video generation architecture we call the asymmetric diffusion transformer, or ASYM-DIT. It's a new technique, but it's really something that improves stability at large scale and balances capacity intelligently between prompt reasoning and visual processing. And so this is another contribution in open architecture that we released to the community. So it performs extremely competently. After release, here's Clem from one of the co-founders, Hugging Face, was tweeting that it was like the #2 model in the market, actually, neck and neck with Hailuo's Minimax model. And so it was extremely compelling from prompt adherence and emotion standpoint. In formal benchmarks, actually, it significantly outperforms many alternatives on the market. And in specifically prompt adherence and emotion quality, it is still the state-of-the-art model. And so with that, actually, one thing that I would like to transition to is we released this base foundation model, this technology that can create these incredible high fidelity dreams on demand. But we also open sourced it. This was incredibly powerful. And one of the most critical things it did enable was it let the community actually begin to fine tune and improve on it. And I like to say at Genmo, we have thousands of researchers actually all around the world who are innovating alongside us, you know, bigger than any other foundation model lab because of this open source nature. And so I want to cover a few really exciting extensions and collaborations. I wish these people could actually come and present themselves about some of these innovations. These are people we have worked with, or they are community members who have actually extended some of the technology on their own. And I think it's really incredible to highlight because the power of open source is really that it moves much faster than the closed providers. One of the most exciting things here is we released very easy low rank adaptation for our model. And so with a few lines of code, you can chuck in a few videos, as few as 20 videos in a directory of any style or motion that you want to replicate. And you can train a LoRa. And so this LoRa is essentially a very compact representation of that style embedded within the parameter space. And so if you actually look at what the outputs look like, here on the left, I mean, you can do all kinds of really interesting effects with explosions, a new motion style that you might want to do in practice for a particular segment. On the right is actually this really interesting effect where there's this zooming effect where you have this infinite zoom that essentially can just be trained with the model, and you can do infinite zoom into anything in the world. The second project I'm really excited about is this Fast Mochi project. So this was actually a direct collaboration we had with UC San Diego. And one of the biggest issues with video generation models is they're too slow. They are somewhere between 10 and 20x slower than real time. And so this means that creators really feel bottlenecked on the creative speed when they're iterating with technology. And so what Fast Mochi was able to do was do 8x faster video generation end to end, which I think was a really incredible outcome. And here's a visualization viscerally of what this ends up looking like here. And so significantly faster overall than what we had out of the box with similar quality. And so absolutely incredible achievement that was only possible through open source innovation. And so this result is, you know, I think far beyond what's possible with even closed models today. Another one that I'm really excited about here was another open source contribution to the Comfy UI ecosystem by a community member here. And so what it's able to do is zero-shot video editing. This is something I thought was really incredible. So they took Mochi one and they, with no further training, were able to make it do end-to-end video editing. So you could take a video such as the one on the left with the bird and make it a dragon. And so that was something that you could essentially reskin end-to-end, like a full re-rendering and re-simulation, all within a single model. And then the bottom here, you could take a dog or a wolf in this case and make it a dragon, and that can happen as well. And so I thought this was really incredible. For example, given an image of a person speaking, you'd be able to add a top hat. And I think it's really interesting to think about what this would take to do with a conventional video editing pipeline, because you would have to basically extract and track the person's head. You may have to rotoscope them out, which would be hugely laborious. You have to then insert the object, relight it, which is really difficult. It might need to be done manually, and then composite it back together, right? But this all can happen end-to-end within a minute again on a local machine on your laptop. And so similarly, you can restyle it as well, or do all kinds of really complex compositional edits. I think this is really incredible, and this begins to start to feel a little bit like the Gemini image editing, interleaved image editing results, but now with video. And I think that was a really interesting result. One of the ones I'm really excited, this one just came out actually just yesterday, it was Music Infuser. And so it actually imbues into the model the ability for video generation models to understand audio. We just heard actually about video to audio from the Stable Audio team, but this does audio to video, and the application they test it with is dancing, which I think is really cool. I think that's one I also really like because one of the things Sora really struggles with, or generally video generation models struggle with, is human motion and gymnastics. It's like kind of the edge case that defeats all video generation models, but by fine-tuning, dancing now becomes possible. And so Mochi has effectively, to the community, solved the gymnastics or dancing benchmark, and I just think that's super incredible. But this aspect of multimodality with audio is another area that I think is really exciting longer term. And so I just wanted to present an overview of Mochi. I left a little bit extra time for question and answer because I actually want to engage with the community, but I think I'm really excited about this vision of dreams on demand. What happens when you make it possible for anybody to take any kind of idea they might have, whether it's a cinematic universe, a video game universe, or our cartoon or anime universe, and be able to actually realize that and actually see that content exist. This is going to create entire worlds that would never exist had it not been for this technology. And so it's, my belief is actually this will grow the creative GDP of the world by orders of magnitude and make us just a net more creative species overall. And so I'm incredibly excited about this. And because of the open source contributions of Mochi 1, I think that that is one of the reasons that Mochi 1 is still such a popular model in the community. We're still investing really heavily to ensure that can continue. It's fully open source as well, so you can scan the QR code and actually just check out the GitHub repo and get it running on your own computer if you like. But with that, thank you very much.
Thank you, Paris. What a powerful line, like dream on demand. That's a really, really great notion. We'll take like 2 questions.
Sorry, I'm having trouble.
So you match these versions faster and quicker?
Yeah, I think there's been a ton of community interest in further improvements. I think controllability and scalability is really important for people. And so it's something we're working to, I would say, stay tuned.
To what extent is there like collaboration with like Hotshot, animators? Like, I think Hotshot, they released an open source model and then they just appeared and then it was like, oh, proprietary. And that was like, that's what they were
kind of up to. And I wondered, do you have much collaboration with those other labs and about like Open Sora 2 and stuff?
Yeah, I know many of these folks. In fact, Yang, who went to Berkeley, like I did my PhD there with the Open Sora project. Yeah, I think people are trying a lot of really diverse ideas. So I'm in contact with a lot of these people. I think for us, like Mochi, the most important thing we wanted to solve was very tactically prompt adherence and motion quality. We felt that past open video models, like some of those that you mentioned, lacked in those 2 dimensions. That was really important for us to solve. But I think open collaboration with academia is really important for us because in some sense it's just a huge force multiplier for us. So we were constantly talking to cool. But you know, we actually do also like that there are other competing open models because they also bring a lot of good ideas that we can import ourselves too.